Hello to all, and welcome to our second video on the series where we are discussing and finding the solutions to the problems, which are the challenger problems, in the all in one set for grade 10, chapter probability. We discussed the first 8 questions in class out of the 10. And why I left the class at 8 questions is because these two questions require a lot of indulgence. Since I had a paucity of time at that time, now I will be able to discuss these two questions, the next two and the last two questions of the challenger set, thus ending the discussion. So let us read the question. In a group of 3 people, the probability that at least 2 people will have the same birthday, ignoring the case of a leap year. Now, the probability, let's mark the probability of 2 people, at least 2 people having the same birthday as PB. PB. If the probability that at least 2 people have the same birthday is PB, we can also say that the probability that all of them have distinct birthdays is PB dash. Because they can either have 2 people celebrating the same birthday or 3 people celebrating the same birthday in one event. The other event where all three are having distinct birthdays. And this is a leap year. Fair enough. So in a group of 3 people, the probability that at least 2 people have the same birthday is. So the question is asking us for PB, but you can easily figure out what will be PB dash, and then we'll do 1 minus PB dash to get the answer. Of course, I have to reiterate the formula for it in the fifth time that 1 minus PB is B dash. That is how I can explain and ratify if there were any conclusion, if there were any confusion on what I just said, on a statement I just said. Right. Fair. Let's see the probability that all of them will have distinct birthdays. Let's name these people. One as say Arish, one as let's say Anil, and the third person as Balram. So let's keep their names in the order of letters. So Arish, Balram, and Kethi. Now we have to consider each of them having distinct birthdays. Now this will require a tad of higher knowledge, but if you're aiming for JE or any other high examination when you'll be going for college, this knowledge is necessary and a very important sphere which I'll be discussing right now. Now, if I have 2 events and I want both of them to get done, and I also know what is the probability of both those events happening. So PA and PB. I want both A and B to get done. What will I do is only multiply PA and PB. But if I want only either of the jobs getting done, which means if A happens and B doesn't happen, I'm fine. If B happens, A doesn't happen, I'm fine. Then I will add the events. This is a very important knowledge you have to use. A very important knowledge, and this knowledge is one which is essential, which you should again sing like a canary to yourself. As these are the level in which they'll ask the Olympiad questions. If you're nursing an ambition to ace the Olympiad examinations, these are the questions which you will have to get to know because these are the patterns and these kind of questions and how we solve them and the secrets and the tips and tricks. All of these are discussed only at Shark Didactics. Back to the question. Let's consider Arish first. Now, Arish, when we are considering, he can take any day. That means the probability of him having any birthday is 90. 365 by 360. But since they have to have distinct birthdays, Balram has to have a distinct birthday than Arish is. So he cannot have on the same day as Arish. We cannot write 365 by 365 again. Rather, we'll write 364 by 365 because now there's a day less for us to consider. Similarly, Kathy cannot take any other of the days. So she will have to take 363 by 360. This will all get us the probability that they'll have distinct birthdays. Let's solve it. So 365 into 364 into 363 by 365 cube, which is 363 into 364 by 365 square when simplified. Now, this is the probability that they have distinct birthdays. The question is asking the probability that at least two or more people have the same birthday, which means either Arish and Balram can have the same birthday, Balram and Kathy can have the same birthday, Arish and Kathy can have the same birthday, or all of them can have the same birthday. What you'll do is simple. 1 minus the probability we got for distinct birthdays. And thus we get the correct answer as 1 minus 363 into 364 by 365 square. The final question of this challenger set to end the discussion, to end the series of discussion. They have chosen two numbers B and C. And this is the question which they are considering replacement. With replacement and without replacement, this should be the difference should be clear to every 10th grader student out there who wants to nurse an ambition for cracking these kind of examinations. With replacement, without replacement, set theory, all these should be clear. So with replacement and the numbers, what set do we have? The set is 1, 2, 3, 4, 5. The first 5 natural numbers. So they chose any two numbers B and C with replacement. So what that means is, if you don't know and you are nursing an ambition, B can take 1, 2, 3, 4, 5. So I arrange these in a bag. I mixed them. I took out a number, saw its value, and wrote B is equal to that value. I saw the chit, and instead of placing it away, I put it back in the box. I put it back in the bag. And then I again mixed it to get C, the second number, is equal to what? That also gives us a meaning that they can be the same number. B and C can both be 1 or 2 or 3 or 4 or 5. So the total number of outcomes then will be 25. Now, what the question is asking is a tad bit different. It's incorporating the knowledge of quadratic equation in this question, which states that the probability that x square plus bx plus c. Now they took b and c. Now they're noting the values. And then they're using those values in a quadratic equation x square plus bx plus c. The probability they want is that the probability that x square plus bx plus c has no real roots or roots which are not real or complex. That is what they want to ask us from this question. Well, now you can keep writing them and solving them and then you'll get the answer. But in examination, you don't have time. So the simple knowledge, the straight away, not straight away, but a simple tactic, which is something which students want to keep at the hindsight and when they're studying quadratic equation, not want to consider, will help in this. That means, again, every aspect of what you are being taught is important in competitive examination. You can't say, I'll keep this in the hindsight, I'll revise these, I'll top the exam. That you can't say. Every concept, every word has to be known to you verbatim from the textbook if you know social, or whatever the teacher has taught you in the classes, in the subject classes. Now, let's consider the general form of the quadratic equation, not the coordinate equation furnished with us to rather not inflict confusion. Let's change the language of the question a little bit. Instead of the question in our set, Shark Didactics, says small b and small c. Let's take this for now as capital B and capital C. That's the only change I want to do. Okay. Now, if I take the general form of the quadratic equation, which is ax square plus bx plus c is equal to 0. One important aspect is this fact, which I'll furnish with you right now. If b square minus 4ac. Now, what I do? I use the b, the a and c. A, b, and c, of course, you must be knowing that they are all constants. I took these and made an expression. B square minus 4ac is called a discriminant of this quadratic equation. And the other thing is this fact, which is very important. If b square minus 4ac is greater than 0, or if b square minus 4ac is equal to 0, in this case, the roots of, let's say in this equation I, the roots of I are real in nature. This is an aspect we have to utilize in this question we have at hand. Now, b square minus 4ac is greater than or equal to 0, then they want real. Fine. But if b square minus 4ac is lesser than 0, then they are non-real. And that is how I am answering the question I have. If b square minus 4ac is negative, its roots are not real. Its roots are complex, if I were to use higher mathematical terms. So, this has to be true in a general equation if we have ascertained that the roots of ax square plus bx plus c are complex or non-real in nature. Fair enough. Now what they have furnished us with is with this equation. They chose capital B and capital C, and now they're making an equation out of it. X square plus BA, capital BX plus capital C is 0. I hope you can see what I'm writing. X square plus capital BX plus capital C is 0 is the equation we have to work on in this question. Now, they are asking for non-real roots. If I place the values and draw parallel with what I have for the general form of equation, I can unveil the hidden one. So now it's easy. That's 1x square plus bx plus c, capital Bx plus capital C is equal to 0. That's our equation. Okay, I got this. Now, for ax square plus bx plus c is equal to 0, b square minus 4ac has to be negative for non-real roots. Similarly, in this one, capital B square minus 4 into 1 into c has to be negative to comply to the question, which can also be written as capital B square minus 4 capital C has to be negative. Now, B can be from 1, 2, 3, 4, 5. That has been given by the questionnaire. C can also be 1, 2, 3, 4, 5. That has been given by the author of this question. So I'm erasing this and I'm writing what is important. That B square minus 4C has to be negative in nature. So let's take different values of B, right? And then let's see what we are getting. Let's take first 1. 1 square minus 4 into some C has to be negative. And the catch is that you have to select it from 1 to 3, 4, 5. If you place the values, you will see that all the numbers will apply. You will see And all numbers will apply because it will give you 1 minus 4, which is minus 3. And if you keep taking the numbers which are more, that'll get you even negative. And even negative is something we want. That's why we'll get over here 5. Now let me put 2. B is equal to 2. So 2 square minus 4 is 4c has to be negative. Now, the problem is 2 square is 4. But if I place c is equal to 1, then it will be 0. But my thought process is asking for it to only be negative and nothing else. That is what the question is asking of us. That means we cannot take c value 1 because that is not compared to what we want. So here we'll get 4. 2, 3, 4, 5 will satisfy. 3 square minus 4c, which means 9c. Now, if I place 1, I'll get 9 minus 4 is equal to 5. That is greater than 0. If I place 2, I'll get 9 minus 8 is 1, which is also greater than 0. The second I place 3, I'll get 9 minus 12 minus 3. 4 and 5, I'll get even more negative. So 3, 4 and 5 are my ballpark. And here I'll get 3. Now I'll go to 4 square. 4 square minus 4c and 0. What we can see here is also a bit peculiar. I repeat that what we can see here is also certainly peculiar in nature. 1 will of course not apply, 2 will of course not apply, even 3 will not apply. And neither will 4 apply. 4 will also not apply in this question. Because 4 square minus 4 into 4 will be 0. And 0 is not something I want. I want negativity, period. So only 5 can be the value of c. I get only 1. Finally, 5 square minus 4c is 0. We can't strike a pattern. Now, 5, 4, 3, 1 we got. So we'll again have to consider. We can't put 1, we'll get 25 minus 4, 21. Similarly, we can't put 2, 25 minus 8 will give us 13. If we put 3, 25 minus 12, sorry. If you put 2, you'll get 25 minus 8, that'll be 70. If you put 3, you'll get 25 minus 4 into 3, 25 minus 12, 30. If you put 4, you'll get 5 square minus 4 into 4, 9. And even if you put 5, you'll get 25 minus 20, which is 5. None of them thus apply. None of them apply in this question. When we are taking b is equal to 5. So here we get 0. Now we consider all these outcomes and add them up. 5 plus 4 plus 3 plus 1 is 0. Plus 0. This gets us 30. And thus, we get the answer to this question as 13 by 25. This places an end to the discussion we were having on the topic of, or rather, solving the questions in the challenges set of the all-in-one book, class 10, chapter probability. Thank you for watching this video.